Hello everyone, welcome back to my channel, my Dragon Kid, and we will be playing Universe Sandbox. And we'll basically just be experimenting in the game. So currently I'm in real time, which it means that every second is 1 second in the game. Or it's the exact same. Why is it going up and down? Yeah, it's not real time anymore at this point. It's supposed to be 1 second a second. It's going over 2. Well, that's a bug. So I have a couple simulations, such as Eclipse Chaos with Eclipse Chaos No Star. And here is Eclipse Chaos, which is just a planet. Where's the motion? Speed 8 kilometers a second, and it's slowing down and going fast again. So if you go closer, you can see all the eclipses. And that stuff is close to a red dwarf. And speaking of red dwarf, let's make it one. Let's just increase the mass. And okay, 2 moons just got ripped up. Probably, if you guys are wondering why, it's most likely because it's the Roche limit. Because the more mass it gets, the heavier it gets. The more closer something gets, the more likely it's going to get ripped apart. For example, 2 of the moons got ripped up because they went past the Roche limit. You guys can search it up what a Roche limit is if you guys want to. See, like all the orbits are unaffected, like the pattern and everything, but it just gets smaller. So the more we increase, the more red dwarf it's going to get. Let's speed it up. You can see it's heating up. You can see the temperature over here. Should see it glowing red in a second. Yep, starting to glow red. And we have created fission in the planet. That's why it's getting so hot. So we now have a red dwarf, and if we want, we can increase it even more to where it becomes a star. A brown dwarf. Is it a brown dwarf or a red dwarf? I think it's called a brown dwarf. Anyway. So the more we increase it, the more likely it's going to become a star. Because of the mass. Because if it gets too big, to a certain point, it's going to like start full fission. Which means it's turning hydrogen to helium. And once it turns full fission, it's just going to be a star. And right now it is a brown dwarf. It is increasing size from an unknown source, but the unknown source is me. So the more we increase it, the more hotter it gets. As you can see, I think now it's getting near red dwarf. As you can see, more moons that moon has an erratic orbit. And they're all getting ripped up. But the more we increase it, then we have a star. A pulsar, from the looks of it. Because the magnetic field is very strong. And now we have a star because it ignited nuclear fission. Because you can see it kept getting hotter and hotter. And now it just started full fission. lot of these elements. Some of the moons are still intact, but most of them aren't. So the more we increase it, we do that, the heavier it gets. As you can see, all the moons just exploded. As you can see, the more we increase it, it looks different. See, we just keep making it heavy and heavier, and now we have a black hole. That's new. I haven't seen a black hole have a pulsar before. I like it though. So if we make it small enough, it'll should just become. Okay, nope. So once it becomes a black hole, it is a black hole. So now we have this, a black hole that has a really strong magnetic field. Let me find the magnetic field. Make a pulsar. There it goes. Now we have a black hole that's a pulsar. You can see the magnetic axis, but the black hole's warping the light. So let's make it 10 times as strong. Let's make it 10 times again. Now it's a black hole with a really strong magnetic field. And about 10 times. So now we have one that really has a strong magnetic field. And then there's 10 times. Then one has a really strong magnetic field. I think those fragments are about to come back soon. You can see, look at that. It looks like a proper black hole. And then we just keep making it bigger and bigger. And that's a really strong magnetic field. Look at that. Realistically, this could be possible. Realistically, it could be possible, but very unlikely. Like, look at this. How far is it away from me? Almost a galaxy. Yeah, it's like that big. That wouldn't be possible, but it can be. Very, very unlikely. So let's make it an actual pulsar. Particle jets. Sure. Now we have that. A jet trail particle. Let's give it 1 GT, or is that Giga Tesla? I think that's what it is. Let's slow it down here. 2 times, 3 times, 5 times, no, whoops. Let's give it 5. So it has like a little disc as well as like a whatever particle things. And I can see it rotates constantly, so it kind of has like a spindle effect. Realistically, this can be possible. I think it already is possible. So now we have a black hole with a really strong magnetic field. What is that? That little thing. It's strange. Let's Let's make it a pulsar and make it like a regular one. And let's give it 2. 3? Yeah, let's give it 3. And let's give it 2. There we go. About 1.5. There we go. So now let's add a planet here. See what happens. Let's add Jupiter around it, for example. Jupiter just gets absolutely demolished. Now we have an accretion disk. Spiraling in towards it now. Until either it gets slingshotted, which is mainly what's happening here, or it gets eaten up. It's getting eaten up. So then we have Planet 9, which is what was it? A planet that we thought existed. Look how close it is to the black hole. So let's put this to like a minute. Why is it doing auto, please? Whoops, did I just put another one? No, not milliseconds. Yeah, sure, let's do milliseconds. Why not? So now let's just spectate Planet 9. Well, no, I don't want to land on the black hole. I get evaporated. Literally. Now let's just watch it being torn apart. Look at that, immediately getting torn apart. Gets warped too. And it's all becoming fragments. And then it gets stretched out. And then it starts orbiting the black hole, which can make it an accretion disk. Sometimes they might have stable enough orbits where it just sits there indefinitely. But most of the time, look at that, it's pulsing now. Let's say it's orbits. And then it just starts getting slingshotted out. So you fast forward enough to where everything's just gone. Let's turn off let's clear all the particles off. Okay, let's not do that. Clear. I thought there was a thing where you can clear all certain tools. Delete all particles of dust. Oh, that drastically increased my performance. How fast is the particle going? 0.85 to the speed of light. Let's make it go the speed of light, shall we? 1. And look at that, it's just going. If you look at it, it's quite slow. That singular particle is going the speed of light. This one right here. Delete all particles of dust, all fragments, clouds, trails. Let me turn off particle jets. Now let's add, let's see, let's add another black hole, shall we? 10 million solar masses. Sagittarius A compared to the black hole. 1 solar mass. Let's make it stay still. That's 10 million. 10 million solar masses. 1 million solar masses. Wait, what? Oh, it's just not showing it. 1 solar mass. 100 solar masses. 10,000. 1 million? Okay, yeah, let's just do 10,000. Nope. Okay, that got eaten up. So let's do that. Make it stay still. Just have like black holes all around it. And then let's have 1 black hole. 1 solar mass. And now let's just sit here and watch what happens. Let's speed it up. All the black holes are going to the must have. And can black holes merge with other black holes? Yes, it has happened before. And now I have an experiment. Let's make it rotate at the speed of light, right? Auto. Rotational period. Can I not scroll? Rotational period. No, we're just gonna make it the speed of light. We're gonna make it a second a second. No, that's a minute. Whoops. 1 second a second. There we go. This is all happening in 1 second, by the way. I probably should have added an epilepsy warning. Look at that, now look, it's going so slow. Well, I guess that'll be the end of the video. Hopefully, I'll see you guys again. And peace out.